Actin and myosin, the good times of muscle contraction. So we've got our Z line right here. Our myosin is this little fuzzy one right here. And our actin is the red one right here. So now, just in case you don't remember or you didn't do the reading, the myosin has little golf club-like heads, and what it does is it scoots the actin towards each other. From the end of the actin to the end of the actin right here is the H zone. So as we contract, you'll see the H zone gets smaller as the sarcomere, as the Z lines get closer together, so the sarcomere is shrinking. Well, how does it do that? All these little ions floating around here are calcium. And this is a blow up of actin. So in your notes, I know there's a section that talks about troponin and tropomyosin, and this is what you have to know. Actin, the reason you're not always contracted is because you have these little ropes that cover the binding sites on the actin. This little rope is called tropomyosin. Oh, so there's the actin, is the little red things. And the tropomyosin is a rope-like structure that covers the binding sites. And then you've got troponin. And troponin is a doorknob on this door. I know that sounds kind of weird, but in order to open the door, you have to grab onto the doorknob. And that's what's going to happen. Calcium would be like your hand. It comes, it binds to the troponin, which then pulls on the door, and it exposes the binding sites. And the little golf clubs on the myosin can dig in. It's really cool. So we're going to go to a different little movie here. Where does the calcium come from? If we're going to have calcium, where does it come from? So we learned that you have the sarcoplasmic reticulum, and all of the calcium is floating around in there. And now we're going to blow up one piece of actin, and then we've got our myosin filament here. And it does have multiple heads, because remember, it's not just one molecule of actin, there are hundreds of them. So now we saw the calcium bind to the troponin. Watch what happens. It's going to pull the door open. Without the calcium, we get none of this. So that's why you need to eat a lot of calcium. So it exposes the binding sites. Now these little spots right here are going to dig into the binding site and pull the actin closer to each other. So now we've got ATP, adenosine triphosphate, and the ATP is 3 phosphates right here. When one breaks off, it becomes ADP, but that releases energy. Watch, we've got energy, which changes how the head of the myosin reacts so that it can dig into the actin. Okay, just to repeat, this is going on all the way around this myosin fiber, not just here. So to repeat, we've got troponin right here, pulling on the tropomyosin, exposing the actin site or active sites. So now our myosin digs in, and it's going to, this is called a cross bridge, and it's going to contract, and it's going to pull the actin together. So there should be another molecule over here, but we're not seeing it right now because we're blowing up one. And that's how it moves. Now, in order to let go, we have to have more ATP. Oh, there it comes. That's why you need lots of energy too. Notice the calcium is still there. If the calcium is still in the system, the binding sites are open. In order to get rid of the calcium, we have to have ATP to push that out. And we'll talk about that later. That's relaxation. So when is this going to happen again? When another one breaks off and we get energy, more ATP. And it happens again and again and again. Now, oh my gosh, what if you died? And you stuck like this, and there's no more energy. That means your muscles would get stuck binding together, and that would be rigor mortis.